Number 4, you are asked to calculate the horizontal and the vertical forces. Likely I gave you the forces, which is Fy and Fx. Apologies for the noise, I'm in my school. So Fy is F sine theta. So my F is 150, sine, the end is 35 degrees. So 150 sine 35. I get 86,04 Newton, and that should be upward. Then my Fx is F cos theta, which is 150 cos 35 degrees. 150 cos 35, it's 122, 122,87 Newton. So Fx is 122,87, and the direction for Fx is to the right. So now that should be 2 marks and then another 2 marks. So this is your X component and this is your Y component. Some teachers, they use FV for F vertical. So you might find your teacher using FV there and FH for this one. Force horizontal, force vertical. So don't get confused in that line. Now, the next question is, let's calculate the frictional force. So to calculate the frictional force, which is number 5, remember you have the formula in the formula sheet which is saying Fk is equal to mu k normal. So if you want to calculate the frictional force, they give us the mu k to be 0,21 in the question. So that should be 0,21. We've calculated the normal force. We calculated the normal force over there to be 423,96. What would be the frictional force? 0,21 times 403,96. So I get my frictional force to be 84,83 Newton. Direction is left. Okay, now the last question for 3 marks, they said we must calculate the acceleration of the 50 kg block. Now we're going to use Newton's second law to do that calculation, and this formula is when you also get it in your formula sheet. F net is equal to NA. The net force acting on the object, remember the object is moving in the horizontal direction. So this three-body diagram is very, very handy when you are doing your calculation, whether they are vertical calculation or your horizontal calculation. So this three-body diagram is your life rather than this one. So you should be able to navigate between those both of them. So you should be able to draw this one as well. So now this will show us the forces which are horizontal. There are only 2 forces which are horizontal, which are acting on the object. It's the frictional force and Fx. Now we need to choose the direction as well. You will expect the system to move to there, to the right. So I will choose right to be positive. So it means my Fx will be positive, while my friction will be negative. So I'm going to say Fx minus friction is equal to Na. Now Fx it's there, it's F cos theta minus friction is equal to Na. Fx, we did calculate it though over there, but let's just be good and substitute again. So we're going to have 150 cos 35 degrees minus the friction. We also calculated over, where's my friction? Over there. So there's my friction. It's 84,83. The mass of the object is 50, and then A, we want to find the value of A. So 150 cos 35 degrees minus 84,83, I'm getting 38 0.040, and that would be equal to 58. Then you divide by 50 both sides. So the value for A will be 0.76 meters per second squared. Remember, you were calculating acceleration. So another question that they can ask you lastly here, it will be along the lines of, can you explain the meaning of 0.76? What does it mean? So remember, this is an acceleration. An acceleration is A is equal to Vf minus Vi over delta t. Acceleration is the rate of change in velocity, or change in velocity per unit time. So now the acceleration is what? Is 0.76. So what does that mean? It means that my change in V, A is my change in V over change in time. It means that my change in V is 0.76 divided by 1 second. So this velocity here, which is 0.76 meters per second, is changing for every second. So now the meaning of this, it means that the velocity of the object, changes by 0.76 meters per second. So the speed at which the ball is moving, or the velocity at which the ball is moving, is 0.76 meters per second. And thank you for watching. I'll see you next time.